Right, back for another in the OMG series. Today we are talking about ionic bonding, okay? So here are some awesome sentences to get you started, okay? Ionic bonding is the transfer of electrons between a metal and a non-metal, okay? It's really important to get your head around that the majority of the periodic table, all of this in red, is a metal, okay? We'll mainly be using 1, 2, and maybe a couple in the transition metals, such as aluminium. But you'll mainly be using 1 and 2, and then maybe 1 or 2 from 3. And then getting used to the non-metals, okay? Non-metals, mainly 7 and 6 are the ones that we use. And obviously, as you get closer back up to 1, there's less of them, okay? You've got that little step down here, but it's really important that you learn 1, 2 metals. 6, 7, 0, obviously you won't be using it in ionic bonding because they've got full outer shells anyway, okay? So, they create ions, okay? So the metal atoms become positive ions and the non-metal atoms become negative ions. There's a really strong electrostatic force of attraction between the oppositely charged ions, and this is what creates the ionic bond, okay? So if we were just to talk about just flipping back to here, the reason they're so strong and they've got really high melting and boiling points is because of the attraction. Have a look at how we draw out ionic bonding. It could come up as a 6 marker, it could come up as a 1 marker, okay? I'm just going to pick a nice... So, imagine they said form the compound of sodium oxide. The first thing you need to work out is whether it's ionic or covalent. Look them up. Sodium is in group 1, whereas oxygen, or oxide, because it's in a compound, is in group 6, okay? So straight away you should know because we've learnt metals and non-metals. So sodium's in group 1, so this is ionic bonding. It's really important that we get the right type of bonding, get our heads around the right type of bonding. So sodium's in group 1. I'm just going to draw them in their outer shells. So it's easy because group 1, that's their outer shell, and then oxygen, again group 1. So go around like a clock and then pair them up, okay? So straight away you should be able to see that sodium is able to transfer 1 electron there, okay? However, that isn't a full outer shell, okay? This is the only time really where you can add something extra, okay? You can't add anything different. You can only add extra sodiums or extra oxides, and the easiest way to do this is to add an extra sodium, and it goes by there, okay? Make sure you're drawing the arrows to show the transfer. You have to draw the arrows, and then to kind of draw their final stages, okay? So you're going to have sodium. You're going to have 2 sodiums. Put it in a bracket. They've each lost 1 electron, so they're going to have a positive charge, okay? They've each lost 1 electron. Oxygen, then you can draw out its new structure. So 1, 2, 3, 4, 5, 6, okay? Again, in a bracket, there's only 1 of that. It's gained 2 electrons, so it's become more negative because electrons are negative, so it's 2 minus. That's the hard bit, is when you gain something, you become negative. When you lose something, you become positive. They might ask you to write the ionic formula, so just count them up. So I've got 2. The metal always goes first. So I've got 2 sodiums, 1 oxygen. Okay, and that's the kind of thing they might be asking you to do. They might ask for electron structure before and after. So the electron structure before of sodium, so it's got 11 electrons, is 2, 8, 1. The electron structure of oxygen before is 2, 6. And they might ask you for their final electron structure. Remember, you're just basing this on 1 of these. So that their final would be 2, 8 because they've lost an electron. And their final would also be 2, 8 because they've gained 2 electrons. So they might ask you that as well. They're the big things they could ask when it comes to drawing and talking about ionic bonds between this positive and this negative. The larger the positive and the negative, the bigger the attraction. So something that's 3 plus is going to have a larger attraction than something that's 1 plus. So there's the ionic bonding. So we've done that one. The reason I put that in is just to see if you were listening. Okay, obviously pause the screen now and you can kind of get a little bit of extra. Okay, moving on then, you might have to know a little bit back about ionic compounds. So here again are some awesome sentences used. I've just talked about this. Positive and negative ions bonding continuously to form giant ionic lattices. A bit like the covalent bonds, they bond over and over again. So imagine that's your 1 ionic bond there, but over and over again now, forming like a giant ionic lattice. Is very structured. Strong electrostatic force, so high melting and boiling points. Lots of energy to break these bonds. Solid compounds do not conduct electricity because the ions are held firmly in place. However, and this is important to remember, if you melt or dissolve them, so salt, you could melt it. Salt is an ionic compound. then they become free to move, so do conduct electricity. So ionic compounds will conduct electricity in certain conditions, and I already talked about this. Ionic compounds with higher charges, 2+ compared to 1+, there's a larger force between them, and it might be worth like drawing it. So you've got 2+, okay, to a minus, and there's just imagine there's a larger force between them. I'll just draw it bigger and have a plus to a minus. So just compare it like that. There's a bigger force, so it's going to require more energy to break that force than it is that force. That leads to higher melting and boiling points. So the larger the charges, the higher the melting and boiling points. Okay, so I am just going to, and then, so again, you're going to pause the video now and have a go at describing them. Okay. So, which groups are non-metals? The big non-metal ones are group 6 and 7. They're the ones that you're going to use, okay? Obviously, anything, so you could have put group 8. They're also non-metals. And then the beginnings, the tops of 5 and 6, 3 and 4. They've all got certain non-metals, but the big ones with full non-metals are 6 and 7. Describe ionic bonding. It is the transfer of electrons between a metal and a non-metal. Okay, so the transfer of electrons between a metal and a non-metal. Draw the ionic bonding of sodium and oxygen. Give 2 properties of ionic compounds. They have really high melting and boiling points. Okay, high melting and boiling points. Conduct electricity when molten. Okay, really strong, hard to break, strong. When ionic compounds conduct electricity when melted or dissolved. Which is strong, so +2, larger electrostatic bond. Okay, so if you got these all right, that's great. You've obviously revised ionic compounds really well. If you haven't, go back and watch the video and have another go, okay, until you're getting 6 out of 6. It's so important.